What if every thought you've ever had exists within a proposed quantum field that connects your mind to the fabric of the universe itself? What if the boundaries between your consciousness and the cosmos are far more porous than we've been led to believe? Tonight, we're diving into one of the most controversial frontiers in science, where quantum physics meets the mystery of human awareness, and where some researchers are quietly suggesting that your mind might be far more quantum than classical. Welcome to another journey into the depths of scientific wonder. I'm here to guide you through ideas that stretch the boundaries of what we think we know, concepts that whisper of connections between the smallest scales of reality and the vast theatre of consciousness itself. Whether you're settling in for the evening or finding a quiet moment to explore, let your thoughts drift as we venture into territory that challenges everything we assume about the nature of mind and matter. Before we begin, take a moment to consider this. Right now, as you listen to these words, billions of neurons are firing in intricate patterns within your brain. But what if those patterns aren't just electrical signals dancing through biological circuits? What if they're participating in something far more fundamental, something that connects your inner experience to the quantum realm that underlies all physical reality? This isn't science fiction. This is the cutting edge of neuroscience, where Nobel laureates and pioneering researchers are asking questions that would have seemed impossible just decades ago. For most of human history, we've thought of consciousness as something that emerges from the brain, much like steam rises from boiling water. Complex enough neurons firing in complex enough patterns, the thinking went, and somehow awareness appears. It's a tidy story, one that fits neatly into our materialist understanding of the world. But like many tidy stories, it might be incomplete. The quantum revolution began in the early 20th century, when physicists discovered that the microscopic world operates by rules that seem to mock our everyday experience. Particles exist in multiple states simultaneously until observed. Objects separated by vast distances can influence each other in ways that defy classical intuition. The very act of measurement changes what's being measured. For decades, these strange quantum effects were thought to be confined to laboratory conditions, to temperatures near absolute zero, and isolation chambers that keep the quantum realm separate from the warm, noisy world of biology. But something remarkable has been happening over the past few decades. Scientists have begun discovering quantum effects in living systems, operating not in the sterile conditions of physics labs, but in the messy, warm environment of life itself. Plants harness quantum coherence to achieve near-perfect efficiency in photosynthesis. Birds navigate using quantum-sensitive mechanisms in specialized proteins in their eyes. Enzymes use quantum tunneling to catalyze reactions that would otherwise be impossible. And now, some researchers are asking a question that would have seemed absurd just a generation ago. If quantum effects can operate in biological systems, if life itself has learned to harness the strange rules of the quantum realm, then what about the most complex biological system we know? What about the human brain? This question leads us into controversial territory, into research that challenges not just our understanding of consciousness, but our fundamental assumptions about the relationship between mind and matter. It's a realm where Nobel Prize winners collaborate with neuroscientists, where ancient philosophical questions meet cutting-edge physics, and where the boundaries between objective science and subjective experience begin to blur in ways that make some researchers uncomfortable. Deep within every neuron in your brain, there exists a network of tiny protein structures called microtubules. These aren't just passive scaffolding holding the cell together. They're dynamic, constantly changing structures that help organize the neuron's internal architecture. For most neuroscientists, microtubules are interesting, but peripheral to the main story of how consciousness arises from neural activity. But Sir Roger Penrose, the Nobel Prize-winning physicist who gave us revolutionary insights into black holes and the nature of space-time, sees something different when he looks at microtubules. Working with anesthesiologist Stuart Hameroff, Penrose has proposed that these tiny structures might be capable of quantum-level information processing information not through classical electrical signals, but through quantum processes that operate according to the strange rules of superposition and entanglement. The theory, known as orchestrated objective reduction, or OR, suggests that consciousness arises from quantum vibrations within microtubules. These vibrations, according to the theory, can exist in quantum superposition, exploring multiple states simultaneously before collapsing into specific patterns that are associated with conscious experience. It's a radical idea, one that places quantum mechanics at the very heart of human awareness. Critics have been quick to point out the apparent impossibility of this proposal. Quantum effects, they argue, require isolation and extreme cold to survive. The brain is warm, wet and noisy, exactly the kind of environment that should destroy quantum coherence in microseconds. For years this seemed like a decisive objection, but recent experiments have begun to chip away at this criticism. Researchers at the University of Central Florida have found that microtubules can sustain quantum effects for remarkably long periods, even under biological conditions. When they exposed microtubules to visible light, they detected re-emission for up to a second, an eternity in quantum terms, and plenty of time for neurons to communicate with each other. Even more intriguingly, studies with anesthetic drugs have provided indirect evidence for quantum processes in consciousness. When researchers gave anesthetics to test subjects, they found that these drugs reduced how long microtubules could sustain quantum excitations. The correlation is striking. The drugs that eliminate consciousness also disrupt the quantum processes that Penrose and Hameroff believe are linked to consciousness. This is where the research becomes particularly fascinating, because it suggests that consciousness might not emerge from classical neural activity alone, but from a delicate dance between classical and quantum processes. Your thoughts, your awareness, your sense of being you might arise from information processing occurring at scales smaller than anything we previously imagined could influence the mind. As you contemplate this possibility, notice how it might change your relationship to your own thoughts. What does it mean for your sense of self if consciousness operates partially in the quantum realm, where the normal rules of cause and effect become fluid and probabilistic? If consciousness does indeed operate through quantum processes, then we must consider one of the most profound implications of quantum mechanics: entanglement. In the quantum world, particles can become entangled, their properties linked in ways that transcend space and time. When you measure one entangled particle, you instantly gain information about its partner, regardless of the distance separating them. Einstein famously called this spooky action at a distance, and it remains one of the most counterintuitive aspects of quantum mechanics. But what if consciousness, operating through quantum processes in microtubules, could become correlated not just within a single brain, but between different minds? This remains highly speculative, with no scientific consensus supporting such connections. Yet the theoretical possibility raises profound questions about the nature of individual consciousness and our sense of separation from one another. Some interpretations suggest that if our minds operate partially through quantum mechanisms, then the boundaries between individual consciousness might be more porous than we assume. This doesn't mean that thoughts can directly influence external quantum events or that emotions create measurable entanglement between brains. Rather, it suggests that consciousness might participate in the same underlying quantum field that connects all matter and energy. Consider for a moment the implications of this possibility. Every meditation teacher, every mystic, every person who has ever felt a profound sense of connection to something larger than themselves might be touching on a truth that physics is only beginning to understand. The feeling of unity that emerges in deep contemplative states might reflect shared underlying physical principles that underlie the apparent separation between minds. This remains unproven and controversial, but it opens doorways to understanding experiences that have been reported across cultures and throughout history. The sense of expanded awareness that comes in meditation, the feeling of connection that emerges in group contemplative practices, the intuitive knowing that sometimes passes between people who are deeply attuned to each other. All of these might reflect subtle processes operating beneath the threshold of ordinary consciousness. One of the most puzzling aspects of quantum mechanics is the role of observation in determining reality. In the quantum realm, particles exist in superposition, occupying multiple states simultaneously until the moment they are observed. The act of observation somehow selects one possibility from the quantum superposition, collapsing the wave function into a definite state. This raises profound questions about the nature of consciousness and its relationship to physical reality. What constitutes an observation? Does consciousness play a special role in the collapse of quantum wave functions? While most physicists would say that any measurement, conscious or not, can collapse a quantum system, some interpretations suggest that consciousness might have a unique relationship to quantum processes. This doesn't mean that human thoughts directly cause quantum events or that consciousness creates reality through observation. The relationship is far more subtle and remains largely speculative. But it does suggest that consciousness and quantum mechanics might be more intimately connected than we've previously imagined. When you observe your own thoughts in meditation, when you witness the arising and passing of mental phenomena, you might be participating in a process that has deep parallels with quantum observation. The act of conscious awareness, some theories suggest, might involve a kind of selection process occurring within your own neural processes. This is speculative territory, but it offers a framework for understanding why contemplative practices often lead to insights about the nature of mind and reality that seem to transcend ordinary conceptual understanding. The direct observation of consciousness through meditation might provide a unique window into quantum processes that operate at the foundation of awareness itself. Take a breath here and consider how this might relate to your own experience of consciousness. When you pay close attention to your thoughts and perceptions, do you notice something dynamic and fluid about the nature of awareness itself? This direct investigation of consciousness, practiced for millennia in contemplative traditions, might be exploring the same territory that quantum physicists are mapping with their equations and experiments. The discovery of quantum effects in biological systems has revolutionized our understanding of how life operates at the molecular level. Photosynthesis, one of the most important processes on Earth, achieves its remarkable efficiency through quantum coherence. When sunlight hits a plant leaf, the energy doesn't simply travel randomly to the reaction center. Instead, it exists in quantum superposition, exploring all possible paths simultaneously and selecting the most efficient route. This quantum navigation occurs at room temperature, in the wet, noisy environment of living cells. It suggests that evolution has not only learned to tolerate quantum effects, but to harness them for biological advantage. The implications for understanding consciousness are profound. If simple plants can maintain quantum coherence under biological conditions, then the complex neural networks of the brain might be capable of far more sophisticated quantum processes. Birds provide another striking example of biological quantum effects. Many migratory species navigate using quantum-level interactions in cryptochrome proteins located in their eyes. When light hits these proteins, it creates electron pairs that are sensitive to Earth's magnetic field. The birds can effectively sense magnetic fields using these mechanisms, allowing them to navigate across thousands of miles with remarkable precision. These examples demonstrate that quantum effects aren't confined to laboratory conditions, but operate throughout the natural world. They suggest that the warm, wet environment of biological systems, rather than destroying quantum coherence, might actually provide the optimal conditions for certain types of quantum processes to flourish. This realization has profound implications for consciousness research. If biological systems routinely use quantum effects for navigation, energy transfer, and information processing, then it becomes plausible that the brain, the most complex biological system we know, might also harness quantum processes for the generation of conscious experience. The research in this area is still emerging, with many questions remaining unanswered. But the growing body of evidence for quantum biology suggests that we need to fundamentally reconsider our assumptions about the relationship between quantum mechanics and living systems, including the most mysterious living system of all, the conscious mind. As you reflect on these discoveries, consider the possibility that your own awareness might be intimately connected to the same quantum processes that guide birds across continents and allow plants to harvest sunlight with near-perfect efficiency. This connection, if it exists, would place human consciousness firmly within the natural world, while simultaneously revealing that the natural world is far more mysterious and interconnected than we previously imagined. The journey into quantum consciousness is just beginning, and the implications of these discoveries will likely unfold for decades to come. What we're witnessing might be the first glimpses of a new understanding of mind and matter, one that bridges the gap between objective science and subjective experience, between the quantum realm and the world of everyday consciousness. In our next exploration, we'll delve deeper into the experimental evidence for quantum processes in the brain and examine what these discoveries might mean for our understanding of free will, creativity, and the nature of human experience itself. For now, let these ideas settle gently into your awareness, like seeds planted in the fertile ground of an open mind. If you're curious about how these quantum processes might relate to the fundamental nature of consciousness itself, you might find our previous exploration particularly illuminating. Is consciousness a particle? The quantum theory physicists are afraid to confront. There we examine whether consciousness might have properties that parallel quantum particles, a perspective that complements tonight's journey into the quantum mind-universe connection. As we continue our exploration of the quantum mind-universe connection, we find ourselves at the threshold of understanding how consciousness might operate as both a biological and quantum phenomenon. The research emerging from laboratories around the world is painting a picture that challenges our most fundamental assumptions about the nature of awareness itself. Imagine for a moment that your brain is not just a biological computer processing information through electrical signals, but a hybrid system that operates simultaneously in both classical and quantum realms. This isn't merely poetic speculation. Recent experiments are revealing that the boundary between biological and quantum processes might be far more fluid than we ever imagined. Dr. Hameroff, working alongside teams at major universities, has been conducting experiments that probe the quantum properties of microtubules under increasingly realistic biological conditions. When researchers expose these cellular structures to light and measure their response, they find something remarkable. The microtubules don't just absorb and immediately release the energy, as classical physics would predict. Instead, they hold onto that energy, re-emitting it over periods that stretch far longer than quantum theory suggests should be possible in warm, wet biological environments. This sustained quantum activity occurs at temperatures that match those found in living brains, in conditions that include the constant molecular motion and electrical activity that characterizes neural tissue. It's as if these tiny cellular structures have evolved to maintain quantum coherence despite the chaos surrounding them, much like a skilled meditator maintaining awareness despite the turbulence of daily life. The implications become even more intriguing when we consider how anesthetic drugs affect these quantum processes. When researchers introduce anesthetics known to eliminate consciousness in living subjects, they observe a corresponding disruption in the quantum properties of microtubules. The correlation is striking. Substances that reliably turn off conscious awareness also reliably interfere with quantum processes in the very structures that some scientists believe generate consciousness. This correlation doesn't prove causation, but it provides compelling circumstantial evidence that consciousness and quantum processes in the brain might be intimately connected. It's reminiscent of how astronomers first detected black holes, not by seeing them directly, but by observing their effects on surrounding matter. We might be witnessing the quantum signatures of consciousness itself. As you contemplate these possibilities, notice how they might shift your relationship to your own awareness. What does it mean to be conscious if that consciousness emerges from processes that operate according to the strange rules of quantum mechanics, where particles can exist in multiple states simultaneously, and where the act of observation plays a fundamental role in determining reality? Recent advances in brain imaging technology are revealing that neural activity in the brain operates with a precision and coordination that seems almost impossible to achieve through classical processes alone. Billions of neurons fire in complex patterns that must synchronize across different regions of the brain, creating the unified experience of consciousness from what should be a cacophony of competing signals. This orchestration occurs at speeds that challenge our understanding of how biological systems can process and integrate information. Neural signals travel through the brain at velocities that are fast by biological standards, but slow compared to the kind of near-instantaneous coordination often discussed in quantum entanglement. Yet somehow, disparate brain regions achieve a level of synchronization that seems to go beyond the limitations of classical signal transmission. Some researchers are beginning to explore whether quantum processes might provide additional insights into this puzzle. If microtubules within neurons can maintain quantum coherence, then information processing in the brain might not be limited to the relatively slow transmission of electrical signals along neural pathways. Instead, quantum processes could theoretically support coordination between distant brain regions. Drawing analogies to how entangled particles maintain their mysterious connection regardless of the space separating them. This possibility remains highly speculative, with no scientific consensus supporting the idea that quantum entanglement operates between different brain regions. However, it offers a conceptual framework for phenomena that have long puzzled neuroscientists. The binding problem of how the brain integrates information from different sensory modalities into unified conscious experience. The hard problem of how subjective experience arises from objective neural activity, and the combination problem of how individual neural processes combine to create unified awareness. Consider your own experience right now as you listen to these words. Somehow your brain is integrating auditory information with visual processing, emotional responses, memory retrieval, and conceptual understanding to create a single, unified stream of conscious experience. This integration happens so seamlessly that we rarely notice its remarkable nature, yet it represents one of the most sophisticated information processing achievements in the known universe. If quantum processes contribute to this integration, then consciousness might operate as what physicists call a quantum coherence system, where individual components lose their separate identities and function as a unified whole. This isn't intended as mere metaphor. In quantum physics, coherent systems exhibit properties that cannot be understood by analysing their individual parts in isolation. The whole becomes functionally greater than the sum of its parts. One of the most profound mysteries in quantum mechanics is known as the measurement problem. The question of what causes quantum systems to transition from existing in multiple states simultaneously to exhibiting definite properties. This transition, called wave function collapse, appears to occur whenever a quantum system is observed or measured, but the precise mechanism remains one of the deepest, unsolved problems in physics. Some interpretations of quantum mechanics suggest that consciousness might play a theoretically meaningful role in this process. This doesn't mean that human thoughts directly cause quantum events, or that consciousness creates reality through observation. Rather, it suggests that the act of conscious awareness might share structural parallels with quantum measurement occurring within neural processes. When you become aware of a thought, when you notice an emotion arising in your mind, when you observe the contents of your own consciousness, you might be participating in a process that has deep conceptual similarities with quantum measurement. The act of self-awareness could involve the selection or stabilization of specific neural states from a range of possible configurations. Much like quantum measurement selects definite outcomes from quantum probability distributions. This perspective offers a fresh approach to understanding the nature of free will and decision-making. Rather than viewing choices as either completely determined by prior causes or arising from random chance, quantum consciousness theories suggest that decision-making might involve processes that are neither fully determined nor entirely random. Instead, they might represent a third category, events that are influenced by the structure and history of the system without being completely determined by them. This remains a speculative idea, not a proven scientific fact. The relationship between consciousness, free will, and quantum mechanics continues to be debated by philosophers, neuroscientists, and physicists. However, it provides a useful interpretive lens for understanding experiences that seem to transcend the simple dichotomy between determinism and randomness. Take a moment to notice your own decision-making process as you engage with these ideas. How do insights arise in your mind? How do you decide what to accept, what to question, what to explore further? The process might feel neither completely automatic nor entirely under your conscious control, but rather like a creative emergence that draws from both structure and spontaneity. As we delve deeper into the implications of quantum consciousness, we encounter ideas that stretch the boundaries of scientific materialism itself. Some theoretical frameworks suggest that consciousness might not be produced by the brain so much as mediated or organized by neural activity, much like a radio receives signals that exist independently in the electromagnetic field. This perspective, which draws inspiration from both quantum field theory and contemplative traditions, proposes that consciousness might be a fundamental property of reality, comparable in a conceptual sense to electromagnetic or gravitational fields. Individual brains, according to this view, don't generate consciousness but rather interact with a broader field of awareness, focusing and individualizing what is essentially a collective phenomenon. Such ideas remain highly speculative and fall well outside mainstream scientific consensus. They represent attempts to bridge the explanatory gap between objective neural processes and subjective conscious experience, but they do so by invoking concepts that cannot currently be tested or verified through conventional scientific methods. However, these speculative frameworks do offer intriguing perspectives on experiences reported across cultures and throughout history. Moments of expanded awareness that seem to transcend individual boundaries, insights that arise spontaneously during meditation or contemplative practice, and the sense of connection to something larger than personal identity that emerges in various altered states of consciousness. If consciousness does participate in some form of universal field, then the boundaries between individual minds might be more porous than our everyday experience suggests. This doesn't mean that thoughts can directly influence external events or that emotions create measurable entanglement between people. Rather, it suggests that individual consciousness might be usefully compared to waves on an ocean, appearing separate from the surface but ultimately expressions of a deeper unity. As you explore these possibilities in your own contemplative practice, you might notice moments when the sense of being a separate self softens or dissolves temporarily. These experiences, reported by meditators across traditions, might provide subjective insights into the nature of consciousness itself. One of the most intriguing aspects of quantum consciousness theories involves their potential to illuminate the mysterious process of creativity. Throughout history, artists, scientists, and inventors have described moments of inspiration that seem to arise spontaneously from beyond the realm of logical thought. Ideas appear fully formed, solutions emerge to problems that seemed unsolvable, and insights dawn with a clarity that feels both surprising and inevitable. The quantum nature of creativity might help explain why these breakthrough moments often occur during periods of relaxed awareness rather than intense concentration. If creative insights arise from quantum processes in the brain, then they might require the kind of open, non-interfering attention that allows multiple possibilities to evolve naturally before resolving into specific ideas. This perspective aligns with reports from many creative individuals who describe their most productive states as involving a kind of active receptivity rather than forced effort. The mathematician Henri Poincaré famously described how solutions to complex problems would appear to him suddenly while he was engaged in completely unrelated activities, as if his unconscious mind was exploring multiple possibilities simultaneously before presenting him with the most promising option. Recent neuroscience research has begun to map the brain states associated with creative insight, revealing patterns of neural activity that differ markedly from those involved in analytical thinking. These creative states show increased connectivity between normally distinct brain networks, suggesting that insights might emerge from the integration of information across multiple neural systems. If quantum processes contribute to this integration, then creativity might represent moments when the brain's highly parallel information processing capabilities come online, exploring vast numbers of possibilities simultaneously before selecting the combinations that prove most valuable or beautiful or true. Consider your own creative process as you engage with new ideas. Do insights tend to arrive through step-by-step logical progression, or do they sometimes appear suddenly, as if emerging from a realm beyond conscious thought? This direct exploration of your own creative experience might provide clues about the complex dynamics of consciousness itself. As we near the halfway point of our exploration, I want to address one of the most controversial areas where quantum consciousness theories intersect with human experience: the relationship between mind and physical healing. The placebo effect, long dismissed as mere psychological trickery, is now recognized as a genuine physiological phenomenon that demonstrates the profound connection between consciousness and bodily processes. When patients experience real healing after receiving inactive treatments, their brains are generating measurable changes in neurotransmitter production, immune system function, and even gene expression. These changes occur through mechanisms that remain largely mysterious, suggesting that consciousness might influence biological processes in ways that extend beyond current scientific understanding. Some researchers have speculated that quantum processes in the brain might help explain how conscious expectation can produce real physiological changes. This remains highly speculative, and it's important to emphasize that no scientific consensus exists supporting the idea that consciousness directly manipulates quantum events to produce healing. However, the placebo effect does demonstrate that the relationship between mind and body involves mechanisms that science has yet to fully understand. The implications extend beyond healing to encompass the broader question of how consciousness might influence physical reality. While we must be careful not to overstate these possibilities or make therapeutic claims unsupported by evidence, the placebo effect does suggest that the boundary between mental and physical phenomena might be more fluid than traditional scientific materialism assumes. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. As you reflect on your own experiences with the mind-body connection, you might notice moments when your mental state seems to influence your physical well-being. While these experiences don't necessarily involve quantum processes, they do point toward the intimate relationship between consciousness and biological function that quantum theories of mind attempt to illuminate. Perhaps the most profound implication of quantum consciousness research involves the role of the observer in quantum mechanics. In traditional interpretations of quantum theory, the act of observation plays a crucial role in determining the behavior of quantum systems. But if consciousness itself operates through quantum processes, then we face a fascinating recursive situation: conscious observers studying consciousness through methods that might themselves involve quantum observation. This creates what philosophers call a hermeneutic circle, where the instrument of investigation, consciousness, is also the object being studied, It's like trying to see your own eyes without using a mirror, or attempting to bite your own teeth. The observer and the observed become conceptually intertwined in ways that challenge traditional assumptions about scientific objectivity. Some interpretations suggest that this recursive relationship might be fundamental to understanding consciousness itself, rather than viewing awareness as something that observes reality from the outside. Quantum theories propose that consciousness might be woven into the very fabric of reality, participating in the ongoing interpretation of the world we experience. This doesn't mean that consciousness creates reality in some magical sense, or that thoughts directly influence external events. Rather, it suggests that the traditional division between subject and object, observer and observed, might be an artifact of classical thinking that becomes less clear at the quantum level of description. When you engage in introspective practices like meditation, you might notice this recursive quality directly. The act of observing your own thoughts changes the nature of those thoughts. The awareness that notices mental phenomena is itself a mental phenomenon. Consciousness studying consciousness reveals not a simple subject-object relationship, but a dynamic, self-referential process that might mirror the self-referential nature of quantum measurement itself. This perspective offers a bridge between objective scientific investigation and subjective contemplative inquiry. Both domains involve consciousness investigating the nature of reality, and both reveal aspects of existence that challenge our conventional assumptions about the relationship between mind and world. The discovery of quantum effects in biological systems has fundamentally altered our understanding of how life operates at the molecular level. What once seemed impossible, quantum processes functioning in warm, wet, noisy biological environments, has proven not only possible, but essential for some of life's most important functions. Beyond photosynthesis and avian navigation, quantum effects have been discovered in enzyme catalysis, where proteins use quantum tunneling to accelerate chemical reactions that would otherwise proceed too slowly to sustain life. These enzymes don't just tolerate quantum effects, they've evolved to exploit them, achieving reaction rates that would be impossible through purely classical mechanisms. The implications for consciousness research are profound. If simple biological systems can harness quantum effects for basic functions like energy conversion and chemical catalysis, then the complex neural networks of the brain might be capable of far more sophisticated quantum information processing. Evolution, it seems, has been experimenting with quantum biology for billions of years, long before human physicists discovered the strange rules of the quantum realm. Recent research has revealed quantum effects in systems as complex as the human eye, where the initial stages of vision involve quantum processes in the protein rhodopsin. When light hits your retina, quantum mechanics plays a role in converting photons into the electrical signals that your brain interprets as vision. You are quite literally seeing the world through quantum processes, using biological machinery that has evolved to operate according to the principles of quantum mechanics. This quantum foundation of perception raises intriguing questions about the relationship between consciousness and quantum reality. If the basic processes through which we perceive the world involve quantum mechanics, then our conscious experience of reality might be more intimately connected to quantum phenomena than we previously imagined. As you look around your environment right now, consider that the visual experience you're having involves quantum processes occurring in your eyes and brain. The boundary between the quantum realm and conscious experience isn't some distant theoretical frontier. It's operating in the biological machinery of perception itself. One of the most mysterious aspects of consciousness involves our experience of time and memory. How does the brain integrate past experiences with present awareness and future anticipation to create the continuous sense of self that persists through time? Recent research in quantum biology suggests that this temporal integration might involve quantum processes that operate according to different rules than classical physics. Memory formation and recall involve complex molecular processes that occur at the interface between classical neural activity and quantum molecular dynamics. The proteins involved in memory storage undergo conformational changes that might involve quantum effects, allowing information to be encoded and retrieved in ways that may extend beyond purely classical mechanisms. Some theoretical frameworks suggest that quantum entanglement might play a role in connecting memories across time, creating correlations between past experiences and present awareness that help generate the continuity of conscious experience. This remains highly speculative, but it offers a possible explanatory pathway for the mysterious way that memories can suddenly resurface with startling vividness, as if they were connected to present experience through channels that transcend normal causation. The relationship between consciousness and time has puzzled philosophers and scientists for centuries. Why do we experience time as flowing from past to future when the fundamental laws of physics are largely time-symmetric? Why does consciousness seem to have a unique relationship to the present moment that differs qualitatively from our relationship to past and future? Quantum theories of consciousness suggest that these temporal mysteries might reflect the quantum nature of awareness itself. If consciousness emerges from quantum processes that exist in superposition until observed, then our sense of the present moment might correspond to the resolution of temporal possibilities into definite experiences of now. Notice, as you listen to these words, how your consciousness seems to be localized in the present moment, while simultaneously drawing on memories of the past and anticipations of the future. This temporal integration of awareness might represent one of the most sophisticated achievements of quantum biology, a process that creates coherent, conscious experience from the flux of quantum processes in neural tissue. The hard problem of consciousness, as formulated by philosopher David Chalmers, asks why there is something it is like to be conscious rather than nothing at all. Why should physical processes in the brain give rise to subjective experience? Why isn't the brain simply a sophisticated biological computer that processes information without generating inner awareness? Traditional neuroscience approaches this question by attempting to correlate neural activity with conscious experience, mapping the brain states associated with different types of awareness. While this research has revealed important connections between brain activity and consciousness, it hasn't explained why those correlations should give rise to subjective experience rather than remaining purely objective processes. Quantum theories of consciousness offer a different approach to the hard problem. Rather than viewing consciousness as something that emerges from classical neural activity, they suggest that awareness might be a fundamental feature of quantum processes themselves. In this view, consciousness doesn't emerge from complexity, it's present at the quantum level and becomes organized and amplified by biological structures like microtubules in neurons. This perspective aligns with interpretations of quantum mechanics that assign a special role to observation and measurement. If consciousness is involved in the collapse of quantum wave functions, then awareness might be a basic feature of reality rather than an emergent property of complex systems. Such ideas remain controversial and speculative, falling well outside mainstream scientific consensus. However, they offer a possible conceptual framework for understanding why consciousness seems qualitatively different from other physical phenomena. If awareness were to operate according to quantum principles, then it might possess properties that cannot be reduced to classical physical processes, no matter how complex. As you reflect on your own conscious experience, notice its irreducible, subjective quality. The redness of red, the pain of pain, the joy of joy, these qualitative aspects of consciousness seem to resist explanation in terms of objective physical processes. Quantum theories suggest that this resistance might reflect deeper structural features of awareness that are not yet fully understood, rather than a definitive quantum explanation. Throughout history, contemplative practitioners have reported experiences that seem to transcend the ordinary boundaries of individual consciousness. Deep states of meditation often involve a dissolution of the sense of separate self, expanded awareness that seems to encompass larger fields of experience, and insights that feel like direct perception rather than conceptual understanding. These reports from the laboratory of inner experience align intriguingly with some implications of quantum consciousness theories. If awareness involves processes that extend beyond purely classical neural activity, then contemplative practices that alter brain states might also influence subtle neural dynamics, potentially opening access to modes of consciousness that transcend ordinary waking awareness. Recent neuroscience research has begun to map the brain changes associated with long-term meditation practice. These studies reveal alterations in neural connectivity, changes in brainwave patterns, and modifications in the default mode network that generates the sense of self. Some of these changes involve increased coherence between different brain regions, suggesting that meditation might enhance large-scale neural coordination, which some theories loosely associate with quantum-inspired models of consciousness. This research remains preliminary, and it's important not to overstate the connections between meditation and quantum processes. However, the reports from contemplative practitioners do provide a rich source of phenomenological data about the nature of consciousness that might inform scientific theories about complex brain dynamics, including those that explore quantum analogies. If you have experience with meditation or contemplative practice, you might reflect on moments when your sense of individual awareness seemed to expand or dissolve. These experiences, while subjective and difficult to study scientifically, might provide personal insights into altered states of consciousness that laboratory research is only beginning to explore. The intersection of contemplative practice and quantum consciousness research represents an emerging and exploratory frontier for understanding the nature of awareness. By combining first-person exploration of consciousness through meditation with third-person scientific investigation of brain processes, we might develop a more complete understanding of the mystery of conscious experience. As we approach the final movement of tonight's exploration, we'll examine what these discoveries might mean for our understanding of creativity, death, and the ultimate nature of reality itself. But for now, let these ideas settle into your awareness, like starlight filtering through a quiet evening sky, illuminating possibilities we've barely begun to imagine. As our journey through the quantum landscape of consciousness continues, we find ourselves approaching perhaps the most profound territory of all, the question of what these discoveries might mean for our understanding of death, continuity, and the ultimate nature of existence itself. But before we venture into these deep waters, let us pause to consider how quantum consciousness theories might illuminate one of the most practical and immediate aspects of human experience, the nature of decision-making and choice. Every moment of your life, you face decisions. Some are trivial: which path to take on a walk, what to have for lunch, whether to check your phone. Others feel monumentous: career changes, relationship choices, moments that seem to redirect the entire trajectory of your existence. Traditional science offers two explanations for how these decisions unfold. Either they're completely determined by prior causes, making free will an illusion, or they involve random neural firing that introduces unpredictability without meaningful agency. But quantum consciousness theories suggest a third possibility, one that conceptually transcends this stark dichotomy between determinism and randomness. If your brain operates partially through non-classical processes, then decision-making might involve what physicists call quantum indeterminacy, events that are influenced by the structure and history of the system without being completely determined by them. Imagine your neural networks as systems existing in a range of possible states, exploring multiple possible choices simultaneously until the moment of decision resolves this uncertainty into a specific course of action. This resolution wouldn't be random, but would be influenced by prior neural patterns, your memories, values, intentions, and the subtle patterns of consciousness that make you uniquely you. This remains a speculative idea, not a proven scientific fact. The relationship between quantum mechanics and free will continues to be debated by philosophers and scientists alike. However, it offers a useful interpretive model for understanding the lived experience of choice-making that feels neither completely automatic nor entirely arbitrary, but rather like a creative emergence that draws from both structure and spontaneity. Take a moment now to reflect on a recent decision you've made. Can you recall the moment when uncertainty resolved into clarity, when multiple possibilities collapsed into a single chosen path? This subjective experience of decision-making might provide introspective clues about complex brain processes operating beneath the threshold of ordinary awareness. One of the most remarkable features of human consciousness is its ability to travel through time, not physically, but through the mysterious landscape of memory. You can close your eyes right now and revisit scenes from your childhood with startling vividness. Hear conversations from years past, or relive moments of joy and sorrow as if they were happening again in the present moment. Recent research in quantum biology has begun to explore whether memory formation and retrieval might involve molecular-scale processes that sit at the boundary between classical and quantum physics. The molecules involved in memory, particularly the proteins that undergo structural changes when memories are formed, exist at this interface between classical and quantum realms. Some theoretical frameworks suggest that memories might be encoded not just in the classical changes to neural connections, but in subtle molecular states within neurons themselves. This hypothesis could help explain why memories sometimes resurface with unexpected vividness, triggered by sensory cues that seem only tangentially related to the original experience. Consider the phenomenon of involuntary memory, made famous by Marcel Proust's description of tasting a Madeleine cake that suddenly transported him back to childhood. These moments of spontaneous recall often feel like more than simple information retrieval. They seem to involve a qualitative shift in consciousness, as if past and present momentarily merge in a way that transcends ordinary temporal boundaries. If memory involves non-classical processes, then the past might not be simply stored as static information, but could remain dynamically linked to present consciousness in ways that allow for these sudden, vivid reactivations of previous experience. This remains highly speculative, with no scientific consensus supporting such mechanisms. However, the subjective experience of memory does seem to involve something more mysterious than simple data retrieval. When you remember a significant moment from your past, notice how the experience involves not just intellectual recall, but a qualitative shift in awareness, as if consciousness itself were reconstructing earlier versions of experience. Perhaps nowhere are the implications of quantum consciousness more intriguing than in the realm of creativity and inspiration. Artists, scientists, and inventors throughout history have described moments when ideas seem to arrive from beyond the boundaries of logical thought, emerging fully formed as if from outside deliberate reasoning. The mathematician Srinivasa Ramanujan claimed that mathematical formulas appeared to him in dreams, presented by a Hindu goddess. The chemist Auguste Kekule discovered the ring structure of benzene after dreaming of a snake seizing its own tail. Paul McCartney heard the complete melody of Yesterday in a dream and worried that he had unconsciously plagiarized it from somewhere else. These accounts of creative inspiration share common features. They occur during relaxed states of consciousness. They involve sudden insights that feel both surprising and inevitable, and they often integrate disparate elements in novel ways that wouldn't emerge through linear thinking alone. Quantum consciousness theories offer a theoretical lens for exploring these creative phenomena. If the brain operates partially through highly parallel processes, then creativity might involve moments when neural systems explore vast numbers of possibilities simultaneously before resolving into specific insights or innovations. This exploration wouldn't be random, but would be guided by the accumulated knowledge, skills, and intentions of the creator. The range of creative possibilities would be shaped by everything the person has learned and experienced, while the final resolution might involve unpredictable elements that introduce genuine novelty. Recent neuroscience research has begun to map the brain states associated with creative insight, revealing patterns of activity that differ markedly from analytical thinking. These creative states show increased connectivity between normally distinct brain networks, suggesting that insights emerge from the integration of information across multiple neural systems. If non-classical processes contribute to this integration, then the moment of creative insight might represent a sudden convergence of possibilities within consciousness itself, where awareness stabilizes one outcome from many potential ideas. As you reflect on your own creative process, whether in art, problem solving, or simply navigating daily life, you might notice moments when solutions or insights seem to arise spontaneously. These experiences might provide personal evidence of the brain's remarkable capacity for integrative thinking. As we delve deeper into the implications of quantum consciousness, we encounter ideas that stretch the boundaries of conventional scientific thinking. Some researchers have proposed that if consciousness operates through quantum fields, it might be subject to phenomena analogous to morphic resonance, a controversial concept suggesting that patterns of activity can influence similar patterns across space and time. This idea, while not accepted by mainstream science, proposes that when organisms learn new behaviors, it becomes easier for other organisms to learn the same behaviors through mechanisms that are not yet understood. Applied to consciousness, this might suggest that insights or shifts in awareness achieved by some individuals could make similar developments more likely in others. This remains purely speculative, with no scientific consensus supporting such phenomena. However, it does offer a metaphorical framework for understanding certain patterns observed in human history. The way similar discoveries often emerge simultaneously in different places, the spread of cultural innovations, or the apparent acceleration of human development in various fields. If consciousness does participate in broader fields of information, then individual awareness might not be as isolated as our everyday experience suggests. The boundaries between minds might be more porous than classical physics would predict, allowing for indirect influences that operate beneath the threshold of ordinary awareness. This doesn't mean that thoughts can directly influence external events, or that consciousness creates reality through intention. Rather, it suggests that individual consciousness might be like ripples on a pond, appearing separate, but ultimately expressions of a deeper medium that connects all awareness. One of the most profound implications of quantum consciousness research involves the nature of self-awareness itself. When you recognize yourself in a mirror, when you experience the sense of being a continuous self persisting through time, when you feel the unique quality of your own consciousness, you might be witnessing highly complex neural processes at their most sophisticated. Self-recognition appears to involve a kind of recursive observation, where consciousness observes itself observing. This creates what might be called a conceptual hall of mirrors, where the observer and the observed interact in ways that generate the mysterious phenomenon we call self-awareness. Recent research in developmental psychology has shown that self-recognition emerges gradually in human development, with clear milestones that can be observed in both behavior and brain activity. The neural networks involved in self-awareness show patterns of connectivity that suggest complex feedback loops between different brain regions. If these feedback loops involve non-classical dynamics, then self-awareness might represent one of the most remarkable achievements of biological organization. The creation of a system that can observe itself, generating the recursive loop of consciousness, recognizing consciousness that characterizes human self-awareness. This perspective offers fresh insights into meditation and contemplative practices that involve observing the mind. When you sit quietly and watch your thoughts, you're engaging in a practice that might directly involve the processes that generate consciousness. The observer observing the observer might be more than metaphor. It might be a useful description of how awareness reflects upon itself. Take a moment to notice your own self-awareness right now. The fact that you can recognize yourself as conscious, that you can be aware of being aware, represents one of the most mysterious phenomena in the universe. If consciousness involves non-classical processes, then this self-recognition might involve dynamics that we're only beginning to understand. Human beings possess a remarkable capacity for empathy, the ability to understand and share the emotional states of others. This capacity appears to involve neural processes that allow us to simulate the experiences of other people, creating a kind of internal resonance with external consciousness. Recent neuroscience research has identified mirror neurons that fire both when we perform actions and when we observe others performing the same actions. This neural mirroring seems to provide a biological basis for empathy, allowing us to understand others by internally simulating their experiences. Some interpretations suggest that if consciousness involves deeper integrative processes, empathy might involve more than just neural simulation. There might be subtle correlational processes between conscious beings that allow for a heightened sense of connection below the threshold of ordinary awareness. This remains purely speculative, with no scientific evidence supporting such mechanisms. However, the subjective experience of deep empathy does sometimes feel like more than simulation. It can feel like direct access to another person's inner state. When you experience genuine empathy with another person, notice the quality of that connection. Does it feel like inference based on external cues, or does it sometimes seem more direct, as if you are accessing their experience from the inside? These subjective reports, while not scientific evidence, do provide phenomenological data that might inform theories about the nature of consciousness. The capacity for empathy represents one of humanity's most remarkable achievements, allowing us to transcend the apparent boundaries of individual consciousness and participate in shared awareness. If integrative processes contribute to this capacity, then empathy might represent a glimpse into the interconnected nature of consciousness itself. As we approach the most profound implications of quantum consciousness research, we must address the question that has haunted human awareness since the dawn of self-recognition: what happens to consciousness when the brain dies? This question lies at the intersection of science, philosophy, and the deepest concerns of human existence. Traditional materialist perspectives suggest that consciousness is produced by neural activity and therefore ceases when the brain stops functioning. From this view, death represents the complete termination of individual awareness, a return to the nothingness that preceded birth. However, quantum consciousness theories introduce alternative, speculative perspectives into this ancient question. If consciousness involves processes that extend beyond classical neural activity, then the relationship between awareness and death might be more complex than simple termination, though no scientific evidence currently supports survival beyond brain function. Some interpretations suggest that the quantum information associated with consciousness might not be destroyed when the brain dies, but might, in theory, be described as remaining encoded in quantum fields that extend beyond individual biological systems. This remains purely speculative, with no scientific evidence supporting the persistence of consciousness after death. It's important to emphasize that these ideas fall well outside mainstream scientific consensus and are best understood as philosophical or theoretical reflections, not claims about afterlife or survival of personal identity beyond death. They represent conceptual possibilities that emerge from certain interpretations of quantum mechanics, not proven facts about the nature of death and consciousness. However, these speculative frameworks do offer new perspectives on questions that have occupied human thought for millennia. They suggest that the relationship between consciousness and physical reality may be interpreted as more nuanced than either pure materialism or traditional religious concepts would suggest. As you contemplate your own mortality, notice how quantum consciousness theories might invite reflection on the mystery of death without necessarily providing definitive answers. They remind us that consciousness remains one of the deepest mysteries in science, and that mystery extends to questions about its ultimate fate. While quantum consciousness theories involve highly technical concepts, their implications might manifest in conceptually practical ways in everyday experience. The observer effect in quantum mechanics, which describes how observation influences quantum systems, is sometimes used as an analogy for how conscious attention influences experience and behavior. This doesn't mean that consciousness directly causes quantum events, or that attention creates reality in some magical sense. Rather, it suggests that the quality of awareness we bring to situations might influence how those situations unfold in subtle ways that operate through entirely natural mechanisms. When you pay close attention to your interactions with others, you might notice that the quality of your attention seems to influence the quality of the interaction itself. This could operate through entirely classical mechanisms such as nonverbal communication and social feedback loops, but it might also involve less well understood processes that are sometimes discussed using quantum metaphors. Similarly, when you bring mindful awareness to your own mental and emotional states, you often find that the very act of observation changes those states. This could reflect the recursive nature of consciousness observing itself, a process that is sometimes compared metaphorically to quantum measurement occurring within awareness itself. These everyday applications of quantum consciousness principles don't require belief in exotic phenomena or supernatural capabilities. They simply involve recognizing that consciousness might operate according to principles that go beyond simple classical models, and that these principles might manifest in the ordinary moments of daily life. As you move through your day, experiment with bringing different qualities of attention to various situations. Notice how the depth and quality of your awareness seems to influence your experience, not through magical thinking, but through the natural responsiveness of complex systems to the type of observation they receive. Carl Jung's concept of the collective unconscious, the idea that human beings share access to universal patterns of meaning and symbolism, has long intrigued psychologists and philosophers. While Jung's original formulation was primarily psychological, quantum consciousness theories have inspired metaphorical ways of thinking about how individual minds might participate in larger fields of awareness. If consciousness operates through quantum fields, then individual awareness could be conceptually framed as accessing information that extends beyond personal experience and memory. This wouldn't involve telepathy or supernatural phenomena, but rather theoretical models that allow consciousness to participate in larger patterns of information as an interpretive framework. This remains highly speculative, with no scientific consensus supporting such ideas. However, it does provide a framework for understanding phenomena that have puzzled researchers across various fields. The apparent universality of certain symbols and archetypes, the way similar insights often emerge simultaneously in different cultures, and the rapid spread of new ideas and practices across human populations. Recent research in network science has revealed that human societies exhibit patterns of information flow that sometimes seem to transcend normal communication channels. Ideas, behaviours, and cultural innovations can spread in ways that suggest invisible connections between apparently isolated individuals. While these phenomena can be explained through classical mechanisms, such as subtle environmental cues and unconscious social influences, quantum consciousness theories suggest that there might also be alternative conceptual models for information sharing that operate at a theoretical level. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. As you reflect on your own access to knowledge and inspiration, you might notice moments when insights seem to arrive from beyond your personal experience and learning. These experiences, while subjective, might provide clues about the ways in which individual consciousness appears to participate in larger fields of awareness and information. Attention represents one of the most fundamental aspects of conscious experience, yet it remains one of the least understood. How does consciousness select certain experiences for focused awareness while relegating others to the background? Why can attention sometimes feel effortless and flowing, while at other times it requires enormous effort to maintain focus? Quantum consciousness theories suggest that attention might operate through hypothetical, quantum-like selection processes, choosing specific possibilities from the superposition of potential experiences. This selection wouldn't be random, but would be influenced by the intentions, interests, and conditioning of the individual consciousness. Recent neuroscience research has revealed that attention involves complex networks of brain activity that coordinate information processing across multiple neural systems. These networks show patterns of synchronization that suggest sophisticated coordination mechanisms operating at speeds that challenge purely classical explanations. If quantum processes contribute to attention, then the act of focusing awareness can be discussed as involving quantum measurement as an analogy within consciousness, much like quantum measurement selects definite outcomes from quantum probability distributions. This perspective offers new insights into contemplative practices that train attention, such as meditation and mindfulness. These practices might be interpreted as working with the selection processes that determine what enters conscious awareness, gradually refining the ability to choose focus over distraction, clarity over confusion. When you practice focusing your attention, whether in meditation or in daily activities, notice the quality of the selection process. How does awareness choose what to focus on? The answer might involve processes that we're only beginning to understand. One of the most mysterious aspects of human consciousness is our capacity to find meaning in experience. Unlike simple information processing, meaning involves a qualitative assessment that seems to transcend objective analysis. How does consciousness determine what matters? What has significance? What deserves attention and care? Quantum consciousness theories suggest that meaning-making might involve conceptual, quantum-inspired processes that evaluate the significance of experiences according to criteria that operate partially outside classical logic. This evaluation wouldn't be arbitrary, but would be shaped by the deep structures of consciousness that have developed through evolution and personal history. The quantum nature of meaning-making might help explain why significance often feels immediate and intuitive rather than derived through logical analysis. When you encounter something meaningful, whether a work of art, a moment in nature, or an insight during contemplation, the recognition of significance often feels instantaneous and certain. This immediate recognition of meaning might reflect processes that evaluate experiences according to complex criteria involving coherence, resonance, and alignment with deep patterns of consciousness. The quantum-inspired metaphor of awareness might describe how experiences are constantly assessed in ways that transcend classical computation. Recent research in cognitive science has begun to reveal that meaning-making involves neural networks that integrate information from multiple brain systems, including those involved in emotion, memory, and abstract reasoning. This integration occurs with remarkable speed and sophistication, suggesting processes that operate according to principles we don't yet fully understand. As you reflect on moments when you've encountered deep meaning in your life, notice the quality of recognition that occurs. Does significance feel constructed through analysis, or does it seem to be directly perceived through more immediate forms of knowing? These experiences might provide clues about the nature of consciousness at work in the recognition of meaning itself. As our exploration deepens, we encounter one of the most profound paradoxes of quantum consciousness. How can individual awareness exist within a quantum field that suggests fundamental interconnectedness? This question touches the very heart of what it means to be a conscious being in a quantum universe. Classical physics supports our everyday sense of being separate individuals, each containing our own private consciousness within the boundaries of our physical bodies. But quantum mechanics reveals a reality where apparent separateness emerges from deeper unity, where individual particles are expressions of underlying fields that connect all of existence. If consciousness operates through quantum processes, then individual awareness might be usefully imagined as waves on an ocean, appearing separate from the surface, but ultimately expressions of a deeper medium that connects all consciousness. This doesn't mean that personal identity is an illusion, but rather that individuality might be compatible with fundamental interconnectedness. This perspective aligns with the reports from contemplative traditions around the world, where practitioners describe experiences of expanded awareness that transcend ordinary boundaries of self without eliminating the capacity for individual function and choice. These experiences suggest that unity and individuality might be complementary aspects of consciousness rather than contradictory opposites. Recent research in neuroscience has revealed that the sense of individual self emerges from the activity of specific brain networks, and particularly the default mode network that generates the ongoing narrative of personal identity. Contemplative practices that alter the activity of these networks often lead to experiences of expanded awareness and reduced sense of separation. If these networks operate partially through quantum processes, then practices that modify their activity might be theoretically framed as working with the foundations of selfhood, temporarily shifting consciousness from individual to more universal modes of awareness. As you examine your own sense of individual identity, notice how it can feel both absolutely real and somehow permeable. The boundary between self and world might be more like a focus of attention than a rigid barrier, allowing consciousness to operate as both individual and universal, depending on the scale of observation. As we approach the culmination of our journey through the landscape of quantum consciousness, it's worth considering what these discoveries might mean for the future of human understanding and capability. We stand at the threshold of what might be a fundamental shift in how we understand the nature of mind and reality. Current research in quantum consciousness remains largely theoretical and experimental, with many questions still unanswered and many claims still unproven. However, the trajectory of discovery suggests that we're moving toward a more complete understanding of consciousness that integrates insights from quantum physics, neuroscience, and contemplative traditions. This integration might lead to practical applications that we can barely imagine today. If consciousness does operate through quantum processes, then we might eventually explore technologies that interface with these quantum aspects of awareness, potentially expanding human cognitive capabilities in ways that transcend current limitations. Such developments would raise profound ethical and philosophical questions about the nature of human identity and the boundaries of technological enhancement. If we can interface with the quantum foundations of consciousness, what does that mean for privacy, autonomy, and the essential nature of human experience? These questions remain speculative, but they remind us that consciousness research isn't just an academic pursuit. It touches the very core of what it means to be human and might ultimately reshape our understanding of our place in the universe. Recent collaborations between quantum physicists, neuroscientists, and technology companies suggest that practical applications of quantum consciousness research might emerge sooner than previously expected. While we must remain cautious about overstating current capabilities, the potential implications are profound. As you contemplate these possibilities, notice how they might change your relationship to your own consciousness. If awareness does operate partially through quantum processes, then every moment of conscious experience might be participating in the same fundamental phenomena that connect all of reality. In the quantum realm, time behaves in ways that challenge our ordinary understanding. Past, present, and future become fluid categories, with quantum events seeming to transcend the linear progression of classical time. If consciousness operates through quantum processes, then awareness itself might have a unique relationship to temporality that differs from our everyday experience of time's passage. Contemplative practitioners have long reported experiences where the ordinary sense of time dissolves, revealing what feels like an eternal present that encompasses all temporal experience. These reports might be interpreted as subjective experiences that resonate with quantum-inspired descriptions of consciousness, where awareness operates according to principles that transcend classical temporality. Recent research in the neuroscience of time perception has revealed that our sense of temporal flow emerges from the integration of multiple brain processes that operate on different timescales. This integration creates the unified experience of flowing time from what are actually discrete neural events occurring in parallel. If these integration processes involve quantum effects, then consciousness might be described as having access to modes of temporal experience that transcend ordinary sequential time. The eternal present reported by contemplatives might reflect the experiential dimension of awareness itself, existing partially outside the classical flow of cause and effect. This doesn't mean that consciousness can literally transcend time or predict the future. Rather, it suggests that awareness might operate according to principles that give it a unique relationship to temporality, allowing for experiences of presence and immediacy that reflect the conceptual foundations of quantum-inspired models of reality. As you settle into this present moment of listening and reflection, notice the quality of nowness that characterizes conscious awareness. This immediate presence might be more than a psychological phenomenon. It can be explored as reflecting the theoretical quantum nature of consciousness itself, existing in a state that is sometimes described as transcending the classical distinction between past, present, and future. As we near the end of our exploration, let us step back to appreciate the remarkable symphony of coherence that quantum consciousness theories propose might be operating within your awareness right now. If these theories prove accurate, then every moment of conscious experience could involve an intricate coordination of quantum processes that span multiple scales of reality. From the quantum vibrations within neural microtubules as hypothesized in certain models, to the large-scale coordination of brain networks, from the quantum biology of perception to the quantum selection processes of attention, consciousness might represent any of the most sophisticated theoretically proposed achievements of quantum coherence in the known universe. This coherence wouldn't be static, but would be dynamically maintained through constant interaction between quantum and classical processes. Your thoughts, emotions, perceptions, and intentions might all emerge from this ongoing dance between different levels of reality, creating the rich tapestry of conscious experience. Recent advances in quantum biology have revealed that living systems have evolved remarkable mechanisms for maintaining quantum coherence under conditions that seemed impossible just decades ago. If the brain represents the most advanced expression of quantum biology, then consciousness can be framed as the ultimate example of life-harnessing quantum processes for sophisticated information processing. This perspective invites a sense of wonder about the nature of your own awareness. Every thought you think, every emotion you feel, every moment of perception and choice might involve quantum processes that conceptually connect your consciousness to the fundamental structure of reality itself. Take a breath and allow yourself to appreciate the mystery and magnificence of conscious awareness. Whether or not consciousness ultimately proves to operate through quantum processes, the very fact that matter has organized itself into forms capable of self-awareness and contemplation represents one of the most remarkable phenomena in the universe. As we conclude our journey through the landscape of quantum consciousness, it's important to acknowledge the vast territories that remain unexplored. While we've examined compelling theories and intriguing research, many fundamental questions remain unanswered, and many claims remain unproven. The relationship between quantum mechanics and consciousness continues to be debated by scientists and philosophers, with no definitive consensus about whether quantum processes play essential roles in generating aware experience. The experimental evidence, while suggestive, remains preliminary, and much work remains to be done before we can draw firm conclusions. However, the questions themselves have value regardless of their ultimate answers. They invite us to examine our assumptions about the nature of mind and reality, to consider possibilities that transcend conventional thinking, and to appreciate the profound mystery of conscious awareness that exists at the heart of human experience. These explorations also remind us that science is an ongoing process of discovery, not a collection of fixed truths. Our understanding of consciousness, quantum mechanics, and their potential relationships will continue to evolve as new research emerges and new perspectives develop. Perhaps most importantly, quantum consciousness theories invite us to maintain a sense of wonder about the nature of our own awareness and its place in the quantum tapestry of existence. The fact that we can even ask these questions, that matter has organized itself into patterns capable of contemplating its own nature, suggests that consciousness represents something genuinely extraordinary in the cosmic order. Whether awareness ultimately proves to operate through quantum processes or emerges through purely classical mechanisms, the mystery remains profound. We find ourselves as conscious beings capable of wondering about consciousness itself, participants in a universe that has somehow given rise to observers capable of studying observation. As these ideas settle into your awareness like gentle ripples on a still pond, you might wonder how this understanding could influence your daily experience of being conscious. While quantum consciousness theories remain largely theoretical, they do suggest ways of approaching awareness that might enrich your relationship with your own mind. Consider developing what we might call quantum mindfulness, a way of paying attention that acknowledges the probabilistic, interconnected nature of conscious experience. This doesn't require belief in exotic phenomena or supernatural capabilities. It simply involves recognizing that consciousness might operate according to principles more subtle and interconnected than classical thinking suggests. When you sit quietly and observe your thoughts, notice how they seem to emerge from a field of potential rather than following strict causal chains. Ideas arise, develop, and dissolve in patterns that feel both structured and spontaneous, much like quantum systems used metaphorically to describe superposition before collapsing into definite states. This quality of emergence characterizes much of conscious experience. Emotions arise from complex interactions between memory, perception, and bodily sensation in ways that resist simple explanation. creative insights emerge from the integration of disparate information in moments that feel both surprising and inevitable. Even basic perception involves the construction of coherent experience from streams of sensory data that are constantly changing and ambiguous. Pay attention to these moments of emergence in your own awareness. Notice how consciousness seems to construct coherent experience from the flux of sensation, thought, and memory. This construction can be interpreted as involving processes that operate according to quantum-inspired principles, selecting specific experiences from vast fields of possibility. The practice of quantum mindfulness doesn't require technical knowledge of physics or neuroscience. It simply involves approaching your own awareness with curiosity about its mysterious nature, recognizing that the simple fact of being conscious represents one of the deepest puzzles in existence. As we prepare to conclude our exploration, let us consider consciousness not as an isolated phenomenon contained within individual brains, but as part of a larger ecology that encompasses the entire universe. This ecological perspective emerges conceptually from quantum consciousness theories, which suggest that awareness might be woven into the fundamental structure of reality itself. From this viewpoint, individual consciousness represents a localized flowering of awareness within a cosmic field that extends throughout space and time. Just as individual organisms exist within and depend upon larger ecosystems, individual minds might exist within and participate in larger fields of consciousness that we're only beginning to understand. This remains a speculative idea, not a proven scientific fact. However, it offers a framework for understanding experiences that seem to transcend the boundaries of individual awareness. Moments of expanded consciousness during meditation, the sense of connection that emerges in group contemplative practices, and the feeling of unity with nature that many people report during profound aesthetic experiences. These experiences might reflect the ecological nature of consciousness itself, moments when individual awareness recognizes its participation in larger patterns of existence. Whether these patterns involve literal quantum fields or represent metaphorical descriptions of psychological phenomena, they point toward an understanding of consciousness that transcends simple individual containment. Recent research in complexity science has revealed that consciousness exhibits many of the characteristics of complex adaptive systems that exist at the edge of order and chaos. These systems show emergent properties that cannot be predicted from their individual components, much like consciousness emerges from neural activity in ways that remain mysterious. If consciousness operates as part of a larger ecological system, then individual awareness might be both autonomous and interconnected, capable of independent function, while participating in collective patterns that span multiple scales of organization. As you reflect on your own conscious experience, notice moments when the boundaries of individual awareness seem to soften or expand. These experiences, whether they occur during quiet contemplation or moments of deep connection with others, might provide glimpses into the ecological nature of consciousness itself. Throughout human history, our greatest advances in understanding have emerged not from certainty, but from wonder. From the ancient philosophers who first questioned the nature of reality, to the quantum physicists who revealed the strange laws governing the microscopic world, progress has flowed from our willingness to embrace mystery and follow questions into uncharted territories. Quantum consciousness research continues this tradition of wonder-driven inquiry. While many questions remain unanswered and many theories remain unproven, the very act of asking these questions expands our conception of what might be possible. It reminds us that consciousness, despite being the most intimate aspect of our existence, remains largely unexplored territory. This sense of wonder has practical value beyond its intellectual satisfaction. When we approach consciousness with curiosity rather than assumptions, when we remain open to possibilities that transcend our current understanding, we create space for new discoveries and deeper insights to emerge. The quantum revolution in physics began with scientists who were willing to abandon classical assumptions and follow experimental evidence into realms that seemed impossible. Similarly, consciousness research might require us to abandon assumptions about the nature of mind and reality that have seemed self-evident but might ultimately prove incomplete. This doesn't mean accepting unproven claims or abandoning scientific rigor. Rather, it means maintaining the kind of open curiosity that allows for genuine discovery while remaining grounded in careful observation and logical analysis. As you continue your own exploration of consciousness, whether through contemplative practice, scientific study, or simply paying attention to the mystery of your own awareness, remember that wonder itself might be one of consciousness's most remarkable achievements. The fact that matter has organized itself into patterns capable of questioning its own nature suggests that curiosity and inquiry are fundamental features of the universe, expressing itself through conscious beings. As our journey through the landscape of quantum consciousness draws to a close, we find ourselves returning to the fundamental mystery with which we began, the nature of awareness itself. Despite all our theories and research, despite the sophisticated models and experimental evidence, consciousness remains profoundly mysterious, perhaps more mysterious now than when we started. This return to mystery isn't a failure of understanding, but a deepening appreciation for the profound nature of what we're investigating. Each answer reveals new questions. Each discovery opens new territories for exploration. The more we learn about consciousness, the more we realize how much remains unknown. Quantum consciousness theories, whether they ultimately prove accurate or not, have served an important function. They've expanded our imagination about what might be possible. They've reminded us that the relationship between mind and matter might be far more intimate and mysterious than classical thinking suggests. These theories have also revealed the deep connections between consciousness research and the most fundamental questions about the nature of reality itself. The study of awareness inevitably leads us into the deepest territories of physics, philosophy, and contemplative inquiry, suggesting that consciousness might be a key to understanding the universe as a whole. This integration of different domains of knowledge, from quantum physics to neuroscience to contemplative traditions, represents one of the most exciting developments in contemporary research. It suggests that a complete understanding of consciousness might require insights from multiple perspectives, each contributing pieces to a puzzle that no single approach can solve alone. As you reflect on the ideas we've explored together, notice how they might influence your relationship with your own conscious experience. Do you find yourself more curious about the nature of awareness, more appreciative of its mysterious qualities, more willing to investigate the depths of your own mind through contemplative practice? These shifts in perspective might be among the most valuable outcomes of our exploration, regardless of whether quantum consciousness theories prove scientifically accurate. The cultivation of wonder, curiosity, and appreciation for the mystery of awareness enriches human experience and opens pathways for continued discovery. In the end, quantum consciousness research invites us into a dance between knowing and not knowing, between scientific understanding and philosophical wonder, between the desire for answers and the appreciation of questions. This dance reflects the fundamental nature of consciousness itself, which seems to exist at the intersection of the known and the unknown. We know that consciousness exists because we experience it directly every moment of our lives. Yet we don't know how it arises, how it relates to physical processes, or what it ultimately is. This combination of intimate familiarity and profound mystery characterizes the entire field of consciousness research. Quantum mechanics adds another layer to this mystery by revealing that the physical world itself operates according to principles that challenge our ordinary understanding of reality. If consciousness emerges from or participates in quantum processes, then awareness might be even stranger and more wonderful than we previously imagined. This strangeness isn't a problem to be solved, but a feature to be appreciated. The weird, counterintuitive nature of both consciousness and quantum mechanics might reflect deep truths about the universe that transcend our everyday categories of understanding. As we conclude our exploration, let us embrace this dance of knowing and not knowing. Let us appreciate what we've learned while remaining humble about what we don't understand. Let us celebrate the progress that's been made while acknowledging the vast territories that remain unexplored. Most importantly, let us remember that we are not outside observers studying consciousness from a distance. We are consciousness investigating itself, awareness exploring its own nature through the remarkable capacity for self-reflection that characterizes human beings. This self-referential quality might be key to understanding consciousness itself. We are the universe becoming conscious of itself, matter organizing into patterns capable of wondering about their own existence. Whether this wondering operates through quantum processes or classical mechanisms, it represents something genuinely extraordinary in the cosmic order. As you drift off to sleep tonight, or continue with your day, carry with you this sense of wonder about the nature of your own awareness. Notice the mysterious quality of conscious experience, the way thoughts arise and pass away, the seamless integration of sensation and perception that creates your moment-to-moment experience of being alive. These ordinary miracles of consciousness, whether they involve quantum effects or not, remain among the most remarkable phenomena in the known universe. The fact that you can be aware of being aware, that you can contemplate the nature of contemplation itself, suggests that consciousness represents a genuine mystery worthy of lifelong exploration. Thank you for joining me on this journey through the quantum landscape of consciousness. Whether these ideas have sparked new questions or simply deepened your appreciation for the mystery of awareness, they've served their purpose. The exploration continues, both in laboratories and in the quiet moments of contemplative inquiry that each of us can pursue. The universe has given rise to beings capable of wondering about the universe itself. That capacity for wonder, that ability to question and explore and contemplate, might be the most quantum phenomenon of all, a phenomenon often described as transcending classical categories and opening into possibilities we've barely begun to imagine. Until we meet again in the realm of questions and wonder, may your consciousness continue to explore the mystery of its own existence. Sweet dreams, fellow travelers in the quantum landscape of awareness. If you're drawn to explore how these quantum perspectives might relate to the fundamental nature of consciousness itself, you might find our previous journey particularly illuminating. Is consciousness a particle? The quantum theory? physicists are afraid to confront. There we examine whether awareness might possess properties that have been compared to quantum particles, a perspective that beautifully complements tonight's exploration of the mind-universe connection. As we continue deeper into this labyrinth of quantum consciousness, we arrive at perhaps the most intimate territory of all: how these discoveries might illuminate the very texture of your inner experience. Not the grand theories or laboratory findings, but the quiet moments when awareness turns inward and encounters the mystery of its own existence. There's something profoundly recursive about consciousness, studying consciousness, like a mirror reflecting into another mirror, creating an infinite regression of awareness observing awareness. If quantum processes do indeed contribute to conscious experience, then every moment of introspection might be understood as involving quantum measurement occurring within the very system being observed. Recent neuroscience research has revealed that self-reflection activates specific neural networks known as the default mode network, creating patterns of brain activity that differ markedly from outward-focused attention. When you pause to observe your own thoughts, when you notice the arising and passing of emotions, when you simply rest in the awareness of being aware, these networks light up in ways that suggest sophisticated, self-referential processing. But here's where quantum consciousness theories offer a fascinating perspective. If these self-reflective processes involve quantum effects, then the act of looking inward might literally change what you find there. Not through magical thinking or reality manipulation, but through the same quantum measurement principles that operate throughout the physical world as described in theoretical models. This remains a speculative idea, not a proven scientific fact. The relationship between quantum mechanics and self-awareness continues to be debated by researchers across multiple disciplines. However, it does offer a framework for understanding why contemplative practices often lead to insights that feel both surprising and self-evident, as if awareness were discovering truths about itself that were somehow already present. When you sit quietly and simply observe the flow of consciousness, notice the quality of this observation. Does it feel passive, like watching clouds pass through an empty sky? Or does it feel more interactive, as if the very act of witnessing were participating in the unfolding of what's being witnessed? One of the most delicate areas where quantum consciousness theories intersect with human experience involves the nature of intention and will. Throughout history, contemplative traditions have suggested that consciousness can influence reality through focused intention, while modern science has struggled to find mechanisms that could support such claims. Quantum mechanics introduces subtle possibilities into this ancient question. In the quantum realm, the act of measurement plays a crucial role in determining outcomes, selecting specific possibilities from superpositions of potential states. If consciousness operates partially through quantum processes, then intention might influence experience in ways that are sometimes theorized to transcend classical cause and effect. It's crucial to emphasize that this doesn't mean thoughts directly cause quantum events, or that consciousness creates reality through intention. The relationship, if it exists at all, would be far more subtle and would operate through entirely natural mechanisms. No scientific consensus exists supporting the idea that mental intention can directly influence external quantum systems. However, there is compelling research suggesting that intention can influence internal states in ways that might involve complex biological and possibly quantum-related processes. Studies of meditation and contemplative practices have revealed measurable changes in brain structure, immune function, and stress hormone levels that occur through mechanisms we don't yet fully understand. Some interpretations suggest that focused intention might influence the quantum processes that contribute to consciousness itself, creating cascading effects that alter neural activity, emotional states, and even physical health. This would operate not through supernatural mechanisms, but through the natural responsiveness of quantum biological systems to the quality of conscious attention they receive, as proposed in certain models. Consider your own experience with intention and attention. When you set a clear intention for your day or focus deeply on a particular goal, do you notice changes not just in your behavior, but in your entire state of consciousness? These subjective shifts might reflect underlying processes operating beneath the threshold of ordinary awareness. The practice of setting intentions in meditation or contemplative practice might be working directly with these quantum aspects of consciousness. Not by forcing outcomes or manipulating reality, but by creating coherent patterns of awareness that allow natural processes to unfold in more harmonious ways. Emotions represent one of the most mysterious aspects of human experience, arising from complex interactions between memory, perception, bodily sensation, and social context in ways that often feel both inevitable and surprising. Quantum consciousness theories suggest that emotional experience might involve processes that extend beyond simple biochemical reactions. Recent research in effective neuroscience has revealed that emotions involve sophisticated coordination between multiple brain systems, including areas responsible for memory, attention, and bodily awareness. This coordination occurs with remarkable speed and precision, creating unified emotional experiences from what should be a chaos of competing neural signals. Some interpretations suggest that this emotional integration might involve quantum coherence processes that allow distant brain regions to coordinate with unusual efficiency, much like entangled particles maintain their mysterious connection across space in quantum theory. This remains purely speculative, with no scientific evidence supporting quantum entanglement between different brain regions. However, the subjective experience of emotion does often feel like more than simple information processing. When you experience deep joy, profound sadness, or overwhelming love, these states seem to involve your entire being in ways that transcend the sum of their neural components. If emotions do involve quantum processes, then the quality of emotional experience might be influenced by the coherence and clarity of consciousness itself. Contemplative practices that cultivate awareness and presence might work by enhancing the functional coherence of emotional processing, leading to greater emotional intelligence and resilience. This perspective offers fresh insights into why mindfulness-based practices often lead to improved emotional regulation. Rather than simply teaching cognitive strategies for managing emotions, these practices might be directly working with the deep organizational principles of emotional experience. Take a moment to notice the emotions present in your awareness right now. Are there subtle feelings of curiosity, wonder, perhaps skepticism about these ideas? Notice how emotions seem to color your entire experience, influencing not just how you feel, but how you perceive, think, and relate to the world around you. This pervasive influence of emotion might reflect the integrative nature of emotional processing, where feeling states create coherent patterns of consciousness that influence all aspects of experience. While this remains a speculative idea, It aligns with reports from contemplative practitioners who describe emotions as fundamental energies that shape the texture of awareness itself. Memory presents one of the deepest puzzles in neuroscience. How does the brain encode, store, and retrieve the vast complexity of human experience? Traditional models suggest that memories are stored in specific neural circuits, like files in a computer's hard drive. But this storage model faces significant challenges in explaining the speed, flexibility, and richness of human memory. Recent research has revealed that memory involves distributed processing across multiple brain networks, with individual memories seeming to be encoded throughout the brain rather than stored in specific locations. This distributed storage resembles what physicists call holographic encoding, where information about the whole is contained in every part. Some theoretical frameworks suggest that memory might function analogously to holographic processes operating at quantum scales within neural tissue. In a hologram, if you cut the image in half, each piece contains the entire image at reduced resolution. Similarly, memories might be encoded in distributed informational patterns that permeate neural networks, allowing complete experiences to be reconstructed from partial cues. This remains a speculative idea, not a proven scientific fact. The relationship between quantum holography and biological memory continues to be explored by researchers, but no definitive evidence yet supports such processes in the brain. However, the subjective experience of memory does exhibit holographic qualities. A single sensory cue, perhaps a familiar scent or piece of music, can suddenly reconstruct entire episodes from your past with startling vividness. These involuntary memories often feel like more than simple information retrieval. They seem to involve a qualitative shift in consciousness that temporarily makes the past present. If memory does involve quantum holographic processes, then the act of remembering might be more creative than we typically assume. Rather than simply retrieving stored information, recollection might involve the reconstruction of past experiences from distributed patterns of information encoded throughout the neural system. This perspective offers new insights into the malleability of memory and the way recollections can change over time. Rather than reflecting the degradation of stored files, these changes might represent the ongoing reconstruction of past experiences using current understanding and context. Consider your own relationship with memory as you reflect on significant moments from your past. Do these recollections feel like fixed records, or do they seem to shift and evolve each time you revisit them? This dynamic quality of memory might reflect the reconstructive nature of conscious recall. Learning represents one of the most remarkable capabilities of conscious beings, allowing us to acquire new skills, understand complex concepts, and adapt to changing environments throughout our lives. But how does consciousness transform experience into knowledge, and how does understanding emerge from the chaos of sensory input and mental processing? Traditional learning theory focuses on the strengthening of neural connections through repetition and reinforcement. While these mechanisms certainly play important roles, they don't fully explain the sudden insights that characterize deep learning. The aha moments when complex concepts suddenly click into place. Some interpretations suggest that learning might involve quantum processes that allow consciousness to explore multiple possibilities simultaneously before collapsing into specific understanding. This quantum exploration wouldn't be random, but would be guided by the structure of existing knowledge and the intentions of the learner as described in theoretical accounts. Recent research in cognitive science has revealed that learning involves the formation of new neural networks that integrate information across previously disconnected brain regions. This integration occurs through mechanisms that operate faster than classical neural transmission, suggesting highly efficient coordination processes. If learning does involve quantum effects, then the quality of consciousness brought to the learning process might influence outcomes in ways that transcend simple effort and repetition. Contemplative states that enhance coherence and clarity of awareness might create optimal conditions for such integrative processes to unfold. This perspective aligns with educational research showing that relaxed, open states of consciousness often facilitate learning better than stressed, effortful states. Rather than forcing understanding through repetition, optimal learning might involve creating conditions that allow exploration of possibilities to occur naturally. Consider your own learning experiences, particularly moments when understanding emerged suddenly after periods of confusion or struggle. These breakthrough moments might reflect non-linear processes operating within consciousness, exploring vast solution spaces before selecting insights that prove most valuable or accurate. The practice of contemplative inquiry, where you hold questions lightly in awareness without forcing answers, might be working directly with these aspects of learning. By maintaining open, receptive attention, you create space for exploration to occur, allowing understanding to emerge from the field of possibilities rather than being constructed through logical analysis alone. Human relationships present some of the most complex and mysterious phenomena in conscious experience. How do separate individuals create shared understanding? What accounts for the deep resonance that sometimes occurs between people? Why do some interactions feel effortless, while others require enormous effort? Recent research in social neuroscience has revealed that successful communication involves sophisticated coordination between different nervous systems. When people are deeply engaged in conversation, their brain waves begin to synchronize, creating shared rhythms of attention and understanding that transcend individual neural activity. Some interpretations suggest that this interpersonal synchronization might involve quantum effects that allow consciousness to resonate across the apparent boundaries between individuals. This remains purely speculative, with no scientific evidence supporting quantum entanglement between different human consciousnesses. However, the subjective experience of deep connection does sometimes feel like more than simple communication through words and gestures. In moments of profound empathy or shared understanding, the boundaries between self and other can seem to dissolve temporarily, creating experiences of genuine intimacy that transcend ordinary social interaction. If consciousness does operate partially through quantum fields, then individual awareness might be more permeable to the influence of other minds than classical physics would suggest. This wouldn't involve telepathy or supernatural phenomena, but rather natural resonance mechanisms between processes in different nervous systems. This perspective offers fresh insights into contemplative practices that cultivate compassion and loving kindness. Rather than simply generating positive emotions toward others, these practices might be creating coherent patterns of awareness that naturally resonate with the consciousness of other beings. Take a moment to reflect on your most meaningful relationships. Can you recall moments when communication seemed to transcend words, when understanding flowed effortlessly between you and another person? These experiences might provide glimpses into the deeply integrative nature of interpersonal connection. The cultivation of presence and awareness in relationship might be working with these aspects of consciousness, creating conditions that allow natural resonance and understanding to emerge. Rather than trying to force connection through effort and technique, optimal relationship might involve maintaining the kind of open, receptive awareness that allows resonance to occur naturally. Perhaps one of the most profound implications of quantum consciousness research involves the nature of personal identity itself. Who are you really? Are you the same person you were 10 years ago? What maintains continuity of self through the constant flux of thoughts, emotions, and experiences that characterize conscious life? Traditional psychology locates identity in memory, personality patterns, and narrative continuity. While these factors certainly contribute to our sense of self, they don't fully explain the immediate, intimate quality of self-recognition that characterizes conscious experience. You know that you are you in ways that transcend conceptual understanding. Some theoretical frameworks suggest that personal identity might involve quantum processes that maintain coherent patterns of consciousness across time. This wouldn't mean that the self is some kind of quantum particle, but rather that the organizing principles that create unified awareness might operate according to quantum principles in certain theoretical interpretations. Recent neuroscience research has identified brain networks responsible for self-referential processing, but these networks show dynamic patterns of activity that change constantly. The sense of being a continuous self emerges from this flux, rather than residing in any fixed neural structure. If identity involves processes, sometimes described as quantum, then the boundaries of selfhood might be more fluid than our everyday experience suggests. The practice of meditation and contemplative inquiry often leads to experiences where the sense of separate self softens or dissolves temporarily, revealing more expansive modes of identity. This doesn't mean that personal identity is an illusion, but rather that selfhood might be more like a process than a thing, more like a pattern of organization than a fixed entity. The so-called quantum self might be simultaneously individual and universal, maintaining personal uniqueness while participating in larger fields of consciousness. Consider your own sense of identity as you listen to these words. Can you locate where you resides? Is it in your thoughts, your body, your memories, or something more subtle? This direct investigation of selfhood might reveal the dynamic nature of identity itself. The cultivation of self-inquiry through contemplative practice might be working directly with the deep foundations of identity, allowing consciousness to explore its own nature beyond the conceptual boundaries of separate selfhood. This exploration can lead to profound shifts in how you relate to yourself and others, revealing dimensions of identity that transcend ordinary psychological understanding. Just as biological organisms require energy to maintain their complex organization, consciousness might require a kind of organizational energy to sustain the coherent patterns that generate aware experience. This metaphorical quantum metabolism would involve the continuous processing of information and the maintenance of coherent states across multiple scales of organization. Recent research in consciousness studies has revealed that aware states require significantly more metabolic energy than unconscious states. The brain during conscious experience consumes glucose at rates that suggest intensive computational activity occurring beneath the threshold of awareness. Some interpretations suggest that this metabolic cost might reflect the energy required to maintain highly coordinated states in neural tissue. If consciousness involves non-classical processes, then aware states would require continuous energy input to prevent decoherence and maintain the delicate patterns that generate subjective experience. This conceptual quantum metabolic perspective offers insights into why consciousness seems to ebb and flow throughout the day, why attention requires effort to maintain, and why contemplative practices often emphasize the cultivation of effortless awareness. The goal might be to optimize the efficiency of consciousness itself, reducing the energy required to maintain coherent aware states. Contemplative practices, like meditation, might work by enhancing the efficiency of this internal regulation, allowing consciousness to maintain coherence with less effort and greater stability. This could explain why experienced meditators often report states of effortless awareness that feel both alert and deeply restful. Consider your own energy levels and their relationship to the quality of your consciousness throughout the day. Do you notice correlations between your overall vitality and the clarity or coherence of your awareness? This relationship might reflect the energetic requirements of conscious experience. The cultivation of practices that support overall health and vitality, from proper nutrition to adequate sleep to regular exercise, might be supporting the biological foundations of consciousness itself. By caring for the biological systems that house awareness, you might be optimizing the conditions for complex integrative processes to flourish. One of the most profound implications of quantum consciousness theories involves how they might manifest in the practical details of everyday experience. If consciousness operates partially through non-classical processes, then the quality of awareness you bring to situations might influence how those situations unfold in ways that transcend simple linear cause and effect. This doesn't mean that thoughts directly create reality or that consciousness manipulates quantum events through intention. Rather, it suggests that awareness might participate in the ongoing creation of experience through subtle integrative processes that operate beneath the threshold of ordinary perception. Recent research in psychology has revealed that the quality of attention brought to activities significantly influences outcomes, not just through improved focus and effort, but through more subtle mechanisms that remain poorly understood. Studies of the observer effect in human behavior show that conscious observation can alter the behavior being observed in ways that extend beyond simple self-consciousness. Some interpretations suggest that these observer effects might reflect complex systemic processes operating in conscious systems. When you bring clear, present awareness to interactions with others, to creative projects, or to problem-solving activities, you might be optimizing processes that enhance the natural unfolding of positive outcomes. This perspective offers practical applications without requiring belief in exotic phenomena. By cultivating presence and awareness in daily activities, you might be working with natural processes that support optimal functioning and creative emergence. Notice as you move through your day how the quality of your attention seems to influence your experiences. When you bring full presence to conversations, do they tend to flow more smoothly? When you approach challenges with open, curious awareness rather than anxious effort, do solutions emerge more naturally? These correlations might reflect the integrative dimensions of consciousness operating in everyday life. Not through magical thinking or reality manipulation, but through the natural responsiveness of complex systems to the quality of conscious attention they receive. As we venture into even more speculative territory, we encounter questions about whether individual consciousness might participate in collective patterns of awareness that transcend personal boundaries. This remains one of the most controversial areas where quantum consciousness theories intersect with reported human experience. Throughout history, cultures have described phenomena that suggest some form of collective consciousness. The apparent coordination of large groups, the simultaneous emergence of similar ideas in different locations, and the sense of shared awareness that emerges in group contemplative practices. Some theoretical frameworks suggest that if individual consciousness operates through shared underlying structures, these structures might be capable of resonance and interference patterns that create larger, coherent organizations. This would be analogous to how individual quantum particles can form collective quantum states that exhibit properties not present in isolated systems. It's crucial to emphasize that no scientific consensus exists supporting the idea that individual consciousnesses can literally entangle, or that thoughts can directly influence events through collective quantum fields. These ideas remain purely speculative and fall well outside mainstream scientific understanding. However, research in network science and social psychology has revealed that human groups do exhibit emergent properties that cannot be predicted from individual behavior alone. The apparent wisdom of crowds in certain decision-making contexts, the rapid spread of cultural innovations, and the coordination that emerges in group activities all suggest some form of collective intelligence. If consciousness does participate in shared informational fields, then group practices like meditation, prayer, or shared contemplation might create conditions that enhance natural coordination and resonance between individual minds. This wouldn't involve supernatural mechanisms, but would operate through the same principles that create coherence in other complex systems. Consider your own experiences in group settings, particularly those involving shared focus or contemplative practice. Have you noticed moments when the group seemed to achieve a quality of awareness or understanding that transcended what any individual could have accessed alone? These experiences, while subjective and difficult to study scientifically, might provide phenomenological data about collective aspects of consciousness that quantum theories attempt to explain. Whether or not these phenomena involve literal quantum effects, they point toward dimensions of awareness that transcend simple individual containment. The phenomenon of dreaming presents one of the most intriguing frontiers for understanding how consciousness might operate through non-ordinary processes. During dream states, awareness continues despite the absence of sensory input, creating rich, complex experiences that often feel as real as waking life while following entirely different rules of logic and causation. Recent neuroscience research has revealed that dreaming involves unique patterns of brain activity that differ markedly from both waking consciousness and other sleep states. REM sleep, when most vivid dreaming occurs, shows neural activity patterns that suggest intensive information processing occurring through mechanisms we don't yet fully understand. Some interpretations suggest that dreams might represent moments when consciousness accesses less constrained modes of experience that are normally filtered out during waking states. The strange, non-linear quality of dream narratives might reflect the nature of information processing when freed from the constraints of sensory reality. This remains purely speculative, with no scientific evidence supporting the idea that dreams involve special quantum processes. However, the subjective experience of dreaming does exhibit qualities that resemble quantum phenomena. The superposition of multiple realities, the non-local connections between distant memories and experiences, and the collapse of dream scenarios into waking memory. If dreaming does involve non-classical dynamics, then the content and quality of dreams might be influenced by the coherence and clarity of consciousness during waking states. Contemplative practices that enhance awareness might create conditions that allow more coherent and meaningful dream experiences to emerge. Many contemplative traditions have developed sophisticated approaches to working with dream states, from Tibetan dream yoga to lucid dreaming practices. These approaches often emphasize the cultivation of awareness that can persist across different states of consciousness, including the dream state. Consider your own relationship with dreams and their role in your overall conscious experience. Do you notice correlations between the quality of your waking awareness and the nature of your dream experiences? This relationship might reflect processes that operate across different states of consciousness. The exploration of dream states through contemplative practice might provide unique access to subtle dimensions of consciousness that are difficult to study through ordinary waking investigation. Dreams might represent a natural laboratory for exploring the nature of awareness itself. One of the most mysterious aspects of conscious experience involves the timing of insight and understanding. Why do solutions to problems often emerge suddenly after periods of not thinking about them? What accounts for the precise timing of creative breakthroughs and moments of clarity? Recent research in cognitive science has revealed that insight often involves the sudden reorganization of neural networks, creating new patterns of connectivity that weren't present during analytical thinking. These reorganizations occur through mechanisms that operate faster than conscious thought, suggesting processes that transcend sequential information processing. Some interpretations suggest that insight might involve parallel exploratory processes that allow consciousness to examine multiple solution spaces simultaneously before resolving into specific understanding. This exploration would be guided by the structure of existing knowledge and unconscious processing that continues during periods of apparent rest. If insight involves such parallel dynamics, then the optimal conditions for breakthrough thinking might be those that support coherence in neural activity. This could explain why insights often emerge during relaxed states, during walks in nature, or in the transition periods between sleep and waking, when the brain exhibits unique patterns of activity. The practice of contemplative inquiry, where you hold questions lightly in awareness without forcing answers, might be creating optimal conditions for insight processes to unfold. By maintaining open, receptive attention, you allow natural problem-solving capabilities to operate without interference from analytical thinking. Consider your own experiences with insight and creative breakthrough. Can you identify patterns in the conditions that seem to support these moments of sudden understanding? These patterns might reflect your unconscious optimization of conditions that support deep integrative processes in consciousness. The cultivation of patience and trust in the natural timing of insight might be working with these dimensions of understanding. Rather than forcing solutions through effort, optimal problem solving might involve creating conditions that allow exploration to occur naturally, trusting that understanding will emerge when the system is ready. Throughout our exploration of quantum consciousness, we've repeatedly encountered connections between theoretical physics and contemplative practice. This convergence isn't accidental. Both domains investigate the fundamental nature of reality and consciousness using different but potentially complementary approaches. Contemplative practices like meditation, prayer, and contemplative inquiry have developed sophisticated methodologies for investigating consciousness from the first-person perspective. These practices often lead to insights about the nature of awareness that align remarkably with implications of quantum consciousness theories. Recent neuroscience research has begun to map the brain changes associated with long-term contemplative practice, revealing alterations in neural structure and function that suggest fundamental changes in how consciousness operates. These changes include increased coherence between brain regions, enhanced attention and emotional regulation, and modifications in the default mode networks that generate the sense of separate self. If consciousness operates partially through non-classical organizational principles, then contemplative practices might be directly working with these foundations of awareness. The cultivation of presence, clarity, and equanimity might optimize conditions for coherence in neural activity, leading to enhanced conscious functioning and expanded access to subtle dimensions of experience. This perspective offers a bridge between objective scientific investigation and subjective contemplative inquiry. Both approaches involve consciousness, investigating the nature of reality, and both reveal aspects of existence that challenge conventional assumptions about the relationship between mind and world. The integration of contemplative practice with quantum consciousness research represents one of the most promising frontiers for understanding awareness. By combining first-person exploration through meditation with third-person scientific investigation, we might develop more complete models of consciousness that honor both its subjective and objective dimensions. Consider your own relationship with contemplative practice, whether formal meditation or simply moments of quiet reflection. Notice how these practices seem to influence not just your emotional state, but the quality and clarity of awareness itself. These changes might reflect optimization of deep integrative processes that support optimal conscious functioning. As we approach the culmination of our journey through quantum consciousness, we return to the fundamental mystery that initiated our exploration: the recursive nature of awareness investigating itself. This self-referential quality of consciousness might be key to understanding its deeper nature and its unique place in the physical universe. In quantum mechanics, measurement plays a crucial role in determining the behavior of quantum systems. But if consciousness itself involves processes analogous to quantum measurement, then we face a fascinating recursive situation. Observers observing observers, consciousness investigating consciousness through methods that themselves involve the phenomena being studied. This creates what philosophers call a hermeneutic circle, where the instrument of investigation is also the object being studied. Rather than being a limitation, this recursion might be fundamental to understanding consciousness and its relationship to reality. Recent developments in quantum information theory have revealed that information and observation play more fundamental roles in physical reality than previously imagined. Some interpretations suggest that consciousness might be relevant to discussions of the measurement problem in quantum mechanics, providing new perspectives on how observation and reality interact. If consciousness does play such a role, then awareness represents something genuinely unique in the physical universe: the capacity for reality to observe and know itself. This self-referential quality might be what distinguishes conscious systems from non-conscious processes. The practice of self-inquiry through contemplative investigation might be directly engaging with this recursive nature of consciousness. When you observe your own thoughts, when you notice the awareness that notices, when you investigate the nature of the investigator. As we reach the end of our journey through the quantum landscape of consciousness, we find ourselves transformed not by answers, but by questions. We began by asking whether your thoughts might exist in quantum fields that connect your mind to the universe itself. Now, perhaps we understand that the question itself might be more important than any definitive answer we could provide. Throughout this exploration, we've encountered compelling theories and intriguing research, from microtubules that might operate as quantum computers to the possibility that consciousness participates in the same strange rules that govern the subatomic world. We've seen how quantum effects flourish in biological systems, how birds navigate through quantum entanglement, how plants achieve near-perfect efficiency through quantum coherence. We've contemplated whether the boundaries between minds might be more porous than we assume, whether creativity emerges from quantum superposition, whether the very act of self-awareness involves processes comparable to quantum measurement occurring within consciousness itself. Yet for all our speculation and wonder, consciousness remains beautifully, mysteriously unresolved. Whether awareness ultimately operates through quantum processes or emerges through purely classical mechanisms, the phenomenon of consciousness continues to represent one of the deepest puzzles in existence. We are conscious beings wondering about consciousness, observers studying observation, participants in a universe that has somehow given rise to the capacity for self-reflection. Perhaps that's the most quantum phenomenon of all, not the specific mechanisms by which thoughts might arise, but the simple, extraordinary fact that matter has organized itself into patterns capable of questioning their own nature. Whether this questioning involves quantum coherence in neural microtubules or classical computation in biological circuits, it represents something genuinely remarkable in the cosmic order. As you carry these ideas forward, let them settle not as fixed beliefs, but as invitations to wonder. Let them inspire you to pay closer attention to the mystery of your own awareness, to notice the recursive quality of consciousness observing consciousness, to appreciate the profound strangeness of being a thinking, feeling, questioning being in a universe that permits such phenomena to exist. The exploration continues both in laboratories around the world and in the quiet moments of contemplative inquiry that each of us can pursue. Until we meet again in the realm of questions and wonder, may your consciousness continue to explore the mystery of its own existence with a gentle curiosity that makes us most human. If you're drawn to explore how these quantum perspectives might relate to the fundamental nature of consciousness itself, you might find our previous journey particularly illuminating. Is consciousness a particle? The quantum theory physicists are afraid to confront. There we examine whether awareness might possess properties that have been likened to quantum particles, a perspective that beautifully complements tonight's exploration of the mind-universe connection.